Now we are going to discuss third problem. This problem is similar to the previous one. Find a bound for the number of iterations needed to achieve an approximation with accuracy 10 to the minus 3 to the solution of this line in the interval 1, 4, right? All right. So we know that the distance between any midpoint and exact root is the modulus of this distance is less than or equal to the length of the interval divided by 2 to the n, right? This is true for any n. Right, this time our interval is 1, 4, close interval, then the right end point is 4, the left one is 1, so the length of that interval 1, 4 is 3. So any midpoint and exact root of function f is less than or equal to 3 divided by 2 to the power n. So what is the accuracy? The accuracy is 10 to the minus 3. So we want to find the minimum number or a bound for the number of iterations. So we want to find a bound for the number of iterations. So this must be less than or equal to 10 to the minus 3, right? So that means I can take this denominator to top, then the exponent becomes negative 2 to the negative n less than or equal 10 to the minus 3. Alright. Okay, so I want to isolate n. Because of that, what am I going to do is I take logarithm both sides. So take log base 10. It is easy. Log base 10 3 times 2 to the minus n less than or equal log base 10 of 10 to the minus 3. You can take this exponent in front of log, and that becomes negative 3 times log base 10 of 10, which is 1, alright, times 1. Okay, so I think you know the product of the log of product of two numbers is equal to sum of logs, right? So this one is log base 10 of 3 plus log base 10 of 2 to the minus n less than or equal to negative 3. Now I take my calculator. You can use your calculator. You can use a non-programming calculator in your Excel, right? Log base 10 of 3. 3 log base 10, which is this, plus this one. You can pull this one. You can take this negative n to the front of log, right? Let's write that. Step 2. So log base 10 of 3, what is the value of that? which is 0.477. 0.477. This is an approximate value. And negative n log base 10 of 2 less than negative 3. What is the value of log base 10 of 2? Let's clear this. Log this one, which is supposed to clear that. Clear everything. Log base 10 of 2, which is alright, 0.3 approximate value. 0.477 minus 0.3n less than or equal negative 3. So that means 3.477 divided by 0.3 less than or equal to n. So let's take our calculator, clear everything. 3.477 divided by 0.3 which is equal to 11.59. Alright, so if you want to get 10 to the minus 3 accuracy, you want to iterate at least 12 times. So this is the bound for the iteration. So you have to do 12 iterations to get 10 to the minus 3 accuracy, right? I think question 5, problem 5 is similar with the previous one. Both are the same, I think. If you change the function, but interval, look at the interval is the same. You get the same answer. Both are the same questions, right? Now let's look at this one. Find an approximation to square root of 3 correct to within 10 to the minus 3 using bisection, the bisection method. Alright, so you know that. So now we are going to discuss the fourth problem, final one. Find an approximation to square root of 3 correct to within 10 to the minus 3 using the bisection method. So 10 to the square root of 3 square. So we want to determine an approximation to 10 to the square root of 3. So you get square root 3. Look at this function. F of x is x squared minus 3. This is a continuous function because this is a polynomial, right? Second degree polynomial. So this is very smooth. This continuous function. If you sub this value, square root f of square root 3, what happened to the function? The function hits 0, right? Square root 3, and you square this one, you you will get 3 minus 3. So this 3, the function hits 0. Then we say square root of 3 is a root of this function, right? It's a root of this function. So this function f is a continuous one. So square root 3 is positive square root 3 is here. So this function is a continuous one. And square root 3 is a root of this function. Let's find this root by using bisection method. So for that we have to choose two points to a closed interval. Let's find. So you know square root of 3 is approximately equal to 1.7 something, right? Then let's choose 1, 2 close interval, 1, 2 close interval, right? Because square root of 3 in between these two numbers, then we can use this. Then you can use a bisection method to find an approximate value for square root of 3, right? So 1, 2 is the closed interval. Then you can compute, you can find the sequence P sub n midpoints, set of midpoints. P sub 1 is the first midpoint. What is the midpoint of this? 1 plus 3 divided by 2, which is 1 point. P sub 1 is 1.5. This is the first midpoint. Then you do that bisection algorithm, right? So function value at, so here it's this denotes P sub 2. This should be P sub 1, right? Initial one. Right, initial one is 1.4, 1.5. The function value at this one is negative 0.75. This is the second one. This should be, oh sorry, this should be here. This should be n sub. This is the second iterative. Second one is this. This is the second midpoint. Then the function value at this point is this. And then let's compute that. This goes on. So what is the accuracy we want? So let's go to that. So what is the accuracy we want? 10 to the minus 3. So within this accuracy we want to find an approximation to the square root of 3. This column represents the function value at this midpoint, at these midpoints, right? So let's this is 10. This is good for 10 to the minus 2 accuracy. This is good for 10 to the minus 3 accuracy. We need what? So we need 10 to the minus 3 accuracy. Right. Okay, then this is good for 10 to the minus 1 accuracy. This is good for 10 to the minus 3 accuracy. So an approximation value to square root of 3 is 1.7319 with 10 to the minus 3 accuracy. 10 to the minus 3. If you want 10 to the minus 4, Yeah, this is 10 to the minus 3 accuracy. So this is 10 to the minus 3 accuracy. Therefore, this is the midpoint. Therefore, this one is an approximation to square root of 3. Then the answer is 1.7319. This is an approximation to square root of 3. Hope you understood this prac class. So I will make a video for the prac classes. See you next time. Alright, see you guys.